Weapons. Rugged, reliable, potent, lethal materiel. A strong right arm for a United States Army capable of defending liberty on any ground, in any environment. Capable of delivering a lethal blow to any aggressor. This lightweight grenade launcher has already proven itself in combat, but it didn't just happen. It was conceived here. All new weapons originate in two-dimensional form, taking usable shape only after years of designing, developing, testing, and finally manufacturing. Directing these complex processes is the United States Army Weapons Command, headquartered at Rock Island, Illinois, an organization with almost 2 centuries of experience in the art of weaponry. The worldwide mission of the Weapons Command is to develop, produce, and maintain weapons and combat vehicles and their fire control for the United States Army. The command also does specialized work for the Air Force and the Marines, and helps to equip nations around the globe through the Military Assistance Program. Functioning much like the board of directors and chief officers of a large corporation, key department heads of the command assemble at staff meetings where information and ideas are exchanged with the commanding general. One of its subordinate commands is Rock Island Arsenal, located near the Weapons Command headquarters at Rock Island, Illinois. In addition to developing new types of artillery and recoil mechanisms, Rock Island fabricates special aircraft ordnance, refurbishes tanks, and designs new items, such as this auxiliary propulsion system for the 155mm howitzer. Another sub-command is the Army's Cannon Center, Waterfleet Arsenal in Waterfleet, New York. Today, as it has in the past, Waterfleet monitors the development and production of all the Army's cannons, recoilless weapons, and mortars. Although not subordinate commands, 2 other organizations perform work under the mission management of the Army Weapons Command. One is Frankfurt Arsenal in Philadelphia. Personnel at Frankfurt procure and develop fire control equipment for tanks, artillery, and combat vehicles, including optical sights, tank periscopes, and all other components that aim or sight large caliber weapons. The other organization near Detroit is the Army Tank Automotive Center, or ATAC. The Weapons Command uses ATAC facilities and personnel to guide the development and production of tanks, self-propelled artillery, and other combat vehicles. The arsenals of the Army Weapons Command today are vital technical centers. They pioneer in the use of the latest materials, tools, and processes, so they can plan for production, and industry can mass produce the weapons the Army needs. They operate in accordance with Army policy, which places primary reliance for the production of weapons systems on private industry. But before industry can manufacture, research and development programs must probe, examine, and test. To accomplish this, Arsenal employees must put their skill, their knowledge, their foresight, and imagination to work. They fall into many diversified categories: analysts, scientists, technicians, specialists, but they share common objectives. They seek to develop new and improved methods of production. They probe for ways to minimize cost without sacrificing quality and effectiveness. And above all, they dedicate themselves to the task of providing the soldier in the field with the finest weapons possible. Now in production, for example, is a new 105mm howitzer developed to augment this one, which has been in service for many years. The objective? A lighter weapon with greater mobility and range. This standard howitzer weighs in at 5,000 pounds. Now, look at the new one again. This improved weapon, thanks to its aluminum carriage, weighs about 3,000 pounds, 1 ton lighter than its predecessor. It also has greater mobility and range. Our engineers at Waterfleet and Rock Island Arsenals also designed it to be air transportable and capable of being dropped by parachute. Another remarkable weapon, also now in production, is the minigun, which uses the standard NATO ammunition. Here you see it being test-fired in an indoor range. Incredible rates of fire, up to 6,000 rounds a minute, are achieved by its 6 revolving barrels. To support the design and development work essential to the creation of new weapons, the Weapons Command carries out wide-ranging research programs, from the study of radioactive cobalt-60 to research with the common spring. The value of such research is illustrated by the fact that a machine gun alone has some 33 springs. For this reason, the command maintains a completely equipped spring laboratory where, by measuring performance on unique spring fatigue testers, design engineers are able to develop stronger, more dependable springs. Evaluation devices, such as this plastic cam simulator, make it possible to pre-check some weaponry components without building costly prototypes. This analog computer laboratory uses highly complex mathematics to solve technical problems. One such technical problem, a machine gun which performed poorly when mounted on helicopters. The computer determined that the mount was too flexible and allowed corrective measures that were achieved with a minimum expenditure of time and money. Still another technique, high-speed photography, which allows slow analysis of mechanisms too fast for the human eye, making minor flaws visible and thus correctable. Obviously, Weapons Command research programs must have a potential for military application. But it is also true that much of what is discovered by its metallurgists, physicists, chemists, and engineers will prove of value to the civilian world. For example, there is Rock Island Arsenal's continuing program to improve the properties of rubber. By blending in various additives, they have developed compounds more resistant to wear, corrosion, and heat. The all-weather mission of the Army requires continuous research to improve a wide variety of lubricants, to develop superior anti-corrosive agents, to find new and better preservatives for military machinery. At Waterfleet Arsenal, chemists perfect new methods of electroplating, in which electrical current deposits one metal upon another to form stronger, more heat-resistant metals and alloys. Another new research program is the study of what are called whiskers. Not found on the face and not made of hair, these whiskers can be made of different metals. They are created by means of a technique that forces gases through molten metal in high-temperature chambers. This tungsten spiral, for example, grew whiskers of tungsten oxide. When embedded in other metal or plastic, whiskers produce composite materials, many of which may have important military application. This tensile testing machine proves their potential, verifying that some aluminum oxide whiskers have a tensile strength of more than 1 million pounds per square inch, 2.5 times stronger than the finest steel. Prototype models, like this one of a new recoil mechanism, are the next step after new weapon designs have been approved. In the prototype stage, various components are individually tested in devices such as this huge pile driver at Waterfleet Arsenal. 60 times a minute, it slams a 20,000-pound weight down on a breech block, subjecting it to the same pressures it would encounter in firing. It eliminates the need to put the breech block in a gun and repeatedly test fire it. In the first year of its operation, the use of the pile driver has saved over $6 million. One of the most important weapons command programs develops firepower for Army aircraft, such as this system, which mounts 2 machine guns on each side of a helicopter. Special development teams chop months off normal delivery schedules, and soon this new armament system was proving itself in Vietnam. An advanced version adds 2 rocket pods. Another development is a nose-mounted grenade launcher, which provides fire support over a wide area. After a combat vehicle or weapon passes its research and development tests, it is turned over to the Production Planning Division, where engineers seek more rapid and economical ways to produce the weapon. At the same time, they try to increase reliability and ease of maintenance. Simultaneously, members of value engineering study each part and operation of the weapon to eliminate unessential features. Meanwhile, quality assurance engineers are drawing up final blueprints, compiling specifications, designing special gauges and test equipment, and making on-the-spot inspections at the contractor's plant to ensure that each item will be produced exactly as specified and on time. Other specialists set up pilot production lines in the arsenals to evaluate the soundness of the manufacturing techniques and procedures called for in the specifications. Modern machinery, automatically controlled by punch tape or cards, typifies the command's insistence on the latest industrial production techniques. Overall supervision of weapons production is the job of the Procurement and Production Directorate at Weapons Command Headquarters. The Production Planning Division has more than 50 industrial engineers and specialists who check on arsenal operation, study new production techniques and modernization programs, and constantly review costs. The Army not only needs to know what to buy 2, 5, even 10 years from now, but also where to buy it and how much it will cost. These men accomplish vitally essential planning, both short and long range, creating masterwork schedules that spell preparedness. While special small quantity orders, such as for this rocket launcher, may be placed with one of the 3 arsenals, the Weapons Command deals primarily with outside industry, doing business and placing orders with hundreds of private companies. Another of their responsibilities is to direct activation of certain industries in times of emergency. Machine tools are just as vital an asset as the planes and tanks our country's stockpiles. The Industrial Readiness Branch directs the mothballing of tools or even entire assembly lines so that if and when needed, they can be quickly activated without any critical time lapse. The other half of the directorate, procurement, is responsible for the awarding of contracts to manufacturers and for the purchase of all materiel for the command. They have increased the use of competitive bidding and fixed price contracts, both of which stimulate private enterprise to produce more economically. These actions have helped the Weapons Command reduce costs by over $40 million in 1 year alone. It is obvious that the contractor, if he is to produce a large quantity of weapons, must be provided with a set of precise drawings and specifications called a technical data package. You are looking at the tech data package for just one item. The package spelled out exactly what the requirements were in detail, with specifics that left no room for misinterpretation. The savings affected paid for the cost of producing the data package many times over. The third major field of activity in Weapons Command Headquarters is supply and maintenance. Here, a single Army-wide distribution system is in operation, providing repair parts, maintenance equipment, and tool kits. It's like running a giant store with 50 worldwide branches. A store that does a $75 million a year business with the Army and other military organizations and stocks more than 52,000 different items. Today, 70% of all supply requirements are determined by automation. Requests are received over this teletype network and are reproduced on punched cards. These cards go to a data processing center where there is a 24-month history of every single supply item. The cards are fed into the computers, which select the supply depot to ship from, readjust the amount of inventory, and calculate when reorders are needed, assuring a 6-month supply on hand, all automatically. The maintenance branch has the task of directing the maintenance of Army weapons all over the world. They develop maintenance procedures, produce technical manuals, and train field maintenance instructors. When needed, they send representatives into the field to service special equipment. The Supply and Maintenance Directorate also has management and field maintenance responsibilities for fire control apparatus. One of the most vital of Army Weapons Command missions is the support of project-managed programs. Programs concerned with weapons systems of urgency, high dollar cost, or complexity, under the direction of a single manager. There is a project manager for combat vehicles, covering the new Armored Command and Reconnaissance carriers. The self-propelled 155mm howitzer. An item that is now being evaluated, the mechanized infantry combat vehicle. And a 20mm rapid-fire weapon system for vehicle use. Here, demonstrating the fact that it can be air-dropped, is the Sheridan weapons system. The Sheridan, considered by many to be the greatest advance in combat vehicles since World War II, is an excellent example of what can be accomplished under the project management system. In addition to its airdrop capability, it can also swim inland waterways. With a gun that doubles as a launcher tube, the Sheridan armored vehicle has added punch in both reconnaissance and assault roles. It can fire a conventional round or the Shillelagh guided missile with deadly accuracy. Now in production, the Sheridan weapons system represents the first application of missile firepower to high-speed armored vehicles. The Sheridan is the forerunner of tomorrow's battlefield weapons, developed today by the Army Weapons Command. In Warren, Michigan, another project manager supervises the development and production of the M60 tank and its family of vehicles, each with specific capabilities for specific missions. This is the versatile fighter of the family, an improved version of the M60. This is the constructive member, a combat engineer vehicle. The M67 is equipped with a flamethrower. This is a new version of an old reliable, updated with diesel power. Most unusual is the armored vehicle launched bridge, which spans obstacles by unfolding from a tank chassis. Here being evaluated, but now in production, is a tank that fires either conventional rounds or guided missiles. Here you see the XM16E1 rifle in the hands of the project manager, who now has prime responsibility for new rifle development. These are some early versions of the M16, or as the original civilian version was called, the AR-15. Important changes have been made since it became a project-managed item. A new flash suppressor has been added. Color has been impregnated into the handguard, pistol grip, and stock, and the action of the working parts has been refined. This weapon, already combat tested, weighs only 6.5 pounds. It can fire a single shot with each pull of the trigger, or fire fully automatically. Its magazine holds 20 of the slightly longer and heavier .22 caliber bullets that deliver its remarkable firepower. Built into all Weapons Command products is a capacity for survival, a pre-tested toughness that will allow it to function on almost any ground in almost any climate. What you have just seen is the Army Weapons Command today, scientific and industrial pioneers, managers of weapons systems from concept to combat. Proud of their history and of their contributions to today's modern Army. But what of the future? What shape is seen for the weapons of tomorrow? Even now, tests are being run on rocket-assisted artillery rounds. They are studying the application of the laser beam to range finding. And constantly working toward bringing new concepts to reality. Here are some concepts of potential weapon systems for the Army of the 1970s. A main battle tank, shotgun, advanced air mobile artillery, an infantry fighting vehicle, armored personnel carrier, a howitzer-armed helicopter, and a prime mover. Beyond that, predictions have less substance, and the shape of weapons to come is determined by the artist's imaginative brush as well as the engineer's realistic slide rule. Even further ahead, there is a time when man will walk on alien soil. But his roots will remain planted on the Earth, an ancient planet on which freedom has never survived without the ability to defend itself. And so long as weapons remain essential to the continuance of our freedom, the Weapons Command will continue to provide the soldier of the United States Army with nothing less than the finest. This lightweight grenade launcher has already proven itself in combat, but it didn't just happen. It was conceived here. All new weapons originate in two-dimensional form, taking usable shape only after years of designing, developing, testing, and finally Directing these complex processes is the United States Army Weapons Command, headquartered at Rock Island, Illinois, an organization with almost 2 centuries of experience in the art of weaponry. The worldwide mission of the Weapons Command is to develop, produce, and maintain weapons and combat vehicles and their fire control for the United States Army. The command also does specialized work for the Air Force and the Marines, and helps to equip nations around the globe through the Military Assistance Program. Functioning much like the board of directors and chief officers of a large corporation, key department heads of the command assemble at staff meetings where information and ideas are exchanged with the commanding general. One of its subordinate commands is Rock Island Arsenal, located near the Weapons Command headquarters at Rock Island, Illinois. In addition to developing new types of artillery and recoil mechanisms, Rock Island fabricates special aircraft ordnance, refurbishes tanks, and designs new items, such as this auxiliary propulsion system for the 155mm howitzer. Another sub-command is the Army's weapons. Rugged, reliable, potent, lethal materiel. A strong right arm for a United States Army capable of defending liberty on any ground, in any environment. Capable of delivering a lethal blow to any aggressor.